Okay, let's begin. Your next homework assignment, number 5, which is related to some spreadsheet functions. That's due on Monday. And I see that many of you brought your computers today. I appreciate that. We're going to do a similar thing on Friday where it would be very useful if you have your computer available. So please bring it to class on Friday. So today we're going to begin talking about some spreadsheet functions for solving complex cash flow diagrams. The material that's related to this is in Chapter 3 of your textbook. And so if you're following along, and I hope you are, you should begin to review Chapter 3 in the book. Speaking of review, let's take a look at one of the weird quirks that we're going to have to keep in mind as we're working with Excel today. Last time I showed you the same slide, but it's important to reiterate what's going on. Let's say, for instance, that you have some revenue coming to you in year 3, $12,500. When you use the built-in functions that Excel has programmed in it, and you're solving for the present value of that future amount, unless you manually override it, it automatically assumes the opposite sign of the amount that's going into the function. And so when you put an amount into the function, it takes an inflow and turns it into an outflow. And I think the reason why it does that is that oftentimes these functions are used in finance when calculating how much loan repayment would be. And so if you have a loan that was positive, then it's going to be an outflow over the course of that loan. So the reminder is that you have to manually correct to adjust it if you want to simply find the present value of an amount, but you don't want it to change the sign. So you have to manually override that sign change tendency that Excel will do. So the negative sign has to be put into the built-in formula. And by the way, these built-in formulas are nothing mysterious. They're the same formulas that I've already given you, like the PV function in Excel and the FV function in Excel. That's just solving F equals P 1 plus I to the N. That's what both the PV and the FV functions are, is you're taking a single amount and you're either finding, if it's a given present value, you find the future value by compounding 1 plus I n years. And then vice versa. If you're solving for the present value and you have a known future value, you just move this portion into the denominator over here. So I don't want you to think that Excel is doing something in the background that you yourself couldn't do, because you could. You could type those equations in manually. And maybe we'll do that just for practice in some future class. But for today, I want us to jump right into these spreadsheet functions. And so here's the form of the spreadsheet function. I demonstrated this in class on Monday, but let's revisit that. First of all, the first field in this function, and by the way, if some of you haven't had as much exposure in Excel as you'd like, then let me start at the very beginning, that when you're giving an automatic function, equals is a way of telling Excel to be aware that a function is occurring. And as you type in PV, as you type that in Excel, it's going to automatically go through its library of existing functions, and it'll give you a little drop-down list of all the possibilities. And so you can already, just by typing the letter P, start to see what some of the possible options are. All right, the parentheses means this is what's going into the function. The first field is the interest rate. If you have a problem where you're given a 7% interest rate, you would not write the number 7 there. You'd write 0.07. And so the first important detail is that the interest rates are entered as a decimal. The next thing is that in the second field is N. And what Excel actually says is NPER, meaning the number of periods. And so if you're working in terms of years, it's asking how many years are you taking whatever amount goes into this function to get it to the present. So N is the number of years or periods. Who knows why we have 2 commas in this function? What's the purpose for having 2 consecutive commas? We're skipping over something, we're ignoring a parameter, exactly right. And the reason why is the built-in function that Excel has in that third field is it's wanting to see what's the recurring payment that it should calculate n periods. And that's not how we're going to use Excel at first. Later on we might put some numbers into the payment field, but we're skipping over the payment field because what we want to do is just apply this function row by row, because each of the amounts in a given year may be different. So it's important to know that we skip over this field and also why, because sometimes we will, sometimes we won't. So I'm going to try and emphasize the times that we do and the times that we don't so that you can get the idea of how those 2 functions behave differently. And then finally, you put in an individual future amount, and the minus sign is because a sign change occurs. All right. So that's how to use the PV function. And your first chance at using it today is going to be on this problem. Let me hand out the paper for the in-class exercise. You can see that it's a pretty complicated cash flow diagram. If I asked you to find the present value of that by hand, it may take you a few minutes. I'm sure you could do it, because ultimately all you'd have to do is first you find the present value of this amount in year 2, then you find the present value in the amount of year 3, and you just keep going and going row by row until you move it all to year 0. All right, so in the handout I give you the column titles that you should use in your solution. And these column titles kind of are like a really big hint. The solution strategy, or like the workflow that you should undertake, is directed by what the column titles are. And so you can see one of the column titles should be year, another one should be the amount, and that means the amount that's actually in that year. And then the third column is going to be the PV of the amount, and it's in that field that you actually start using the PV function. So the first step is to translate this cash flow diagram into a cash flow table. Okay, so start up Excel if you haven't already. And what we want to do is we want to translate the cash flow diagram into a cash flow table. So let me paste it over here. Does everybody have a copy of the in-class exercise? All right. We want to leave a little room at the top because we need to put the interest rate somewhere. So the first cell, A1, I'm going to say I equals, and then I'm going to tab to the next field, and that's where I type 0.07. And you should do the same. So we're just finding a spot where we can define the interest rate. And you can't put it in the same cell, because if I did it like this, I equals 0.07, then that's text. And Excel needs to see numbers. And so that's why I have to separate it into different cells. So I've got the definition and the number in adjacent cells, so that this is really for me. This I equals, it's just so I can visually know what it is. But in all of the functions, I'm going to refer to this number. Okay, so the column titles: year, amount, and PV of amount. All right. Okay, so now take a moment to fill in the years and the amounts that are given in those years. So I'll just pause for a minute and let you fill that in, and then I'll do the same. I'm going to start translating the cash flow diagram into a cash flow table. The nice thing about Excel is it tries to take all of the manual work as much as possible, and so you don't have to type in all those numbers manually. You can just type in the first two, highlight them, and then as you drag down, it will detect and continue the pattern. So you don't have to type the numbers in yourself. All right, and then the amounts, 0. If there's nothing, you should put the number 0, just as a matter of habit. So this is what our cash flow table should look like. Okay, let me show you what you're supposed to do in this PV of amount column. So in this column, we start off with equals to let Excel know we've got a function coming. And then P, you can see as soon as I type in the letter P, these are all of the functions that are built into Excel that start with the letter P. I type in V, and now parentheses. Okay, so for the rate, I could just type in the number. I could just type in 0.07. Well, what's the advantage of me referencing a location rather than typing in the number? Yeah, the advantage is that if I wanted to see what's happening with a different interest rate, then I can just change it in that one spot, and everything else will automatically correct from that. All right, so I'm going to click in the cell location. Now I need to lock the reference by having the dollar signs in front of the letter and the number. And so you can either type those dollar signs in manually or press the F1 button. I'm sorry, F4. So what happens if I don't lock the reference? Yeah, then the I is going to be looking in the wrong spot. So lock the reference. Okay, now NPER means how many periods is it to move that amount to year 0. So let me point to something on the cash flow diagram here. Okay, this amount in year 5, what should the NPER be for that amount? How many periods does it need to go until it's at the present? 5. Yeah, so NPER is going to be different for each row. But for each row that we're doing, it needs to be how many years it's traveling to get to the present. So luckily, we can just use this year reference, and so I'm going to click here. So 0 years, 1 year, 2 years, and so on. Question over here? Oh yeah, I'll talk about that. Yeah, I know exactly what you mean, and I'll demonstrate. Okay, so now we put in the double comma, skip over the payment field, and now we're going to tell it what is the future value in question. So each one of these is individually being treated like a single future value that we're moving back. All right, so minus of the amount. Okay, so that's the function. Type enter. And you'll notice it automatically put dollars because it knows when you're using one of those built-in functions, now we're like the PV function or the FV function, we're talking about currency. I don't really like the way that it automatically formats. It automatically formats so that if we drag this function down, some of the cells turn red. And that's, I don't know, kind of stupid. I think a minus sign would be better. So that's my personal preference. So what I'm going to do is highlight all of these and click currency. And then once you manually force it to the currency formatting style, then it eliminates those reds and the brackets, and it finally gives us the minus sign that maybe is a little bit more understandable. Let me show you what happens if we accidentally put an amount in the payment field. All right, so consider year 2. What's going on in year 2 is we've got a single amount that needs to go to year 0. It's just one amount that we're moving individually. But if I put it in the wrong field, and so the value of that amount, by the way, is $10,917 if we're talking in present terms. But what if I forgot to do the double comma? What would happen? This is important, so it's important to know why sometimes we want to avoid the payment. So if it is in the payment field, what it thinks is there are n payments that are taken to the present. So if you put it in the payment field, it thinks that there were 2 12,500s that it should take to 0. And what really happened is there's a single 12,500 in year 2 that's moving to year 0. So that's what happens, and it gets even more egregious the further down you get. Like this 8,000, which we know if you move 8,000 that many years, it's not going to have as much value. But what if I forgot to do the skip? What if I put it in the payment field instead of the future value? 75,000 versus 2,700. So if I have it in the payment field, it thinks that there's 16 payments in the amount of 8,000, but that's not what we've got. Okay, so then the final step is we want to add everything up. We're going to have like a total field where we say equals sum, and then you highlight all of these PV of amounts. $78,261. Question?
So, as an example where you would use the payment function, if you said quarterly, like sometimes you have to pay things quarterly, then the payment would equal 4?
No.
Oh, okay.
No.
So,
There is a time that we're going to use it, but that isn't one of them.
Okay.
Yeah. Yes?
When we do these, do you want us to leave our cute decimal places for the pennies, or?
Good question. So when you're working in Excel, my personal opinion is that it just makes it too busy and complicated if you show every last penny. So maybe you could, reduce the number of digits that are shown. Just it's less visually cluttered, but the numbers are still there. You can still find out what the answer is. But wherever possible, it might be preferred to eliminate any unnecessary precision. Are there other questions? Yes? Uh-huh. So like you've got a positive 12,500 and you put the minus sign in that fourth field. Mm-hmm. All right, let me take a look. All right, so future values are a little more tricky. I forgot to show you NPV. You're going to love NPV. All right, so if you're working right now, please pause for just a moment so you can see the net present value. It's worth your attention. It's a built-in function. I'm going to here just say NPV, just so I know what I'm doing next to it. It's a built-in function that automatically takes amounts that are in the future to the present, but the numbers you put in should only be amounts that are already in the future. So we are going to select a range of values that contain future amounts. And so the form of it is NPV. We first give it the interest rate, and then we highlight a range of values. So we already know this is the present value of that cash flow. What present value means is if you got a one-time payment of $78,260, that would be the same as receiving all of these amounts over time, assuming the 7% interest rate. Okay, so what NPV you can do is equals NPV, and we reference the rate, 7%, and then I put in a comma, and now I highlight only the amounts that are in the future. And this is really important. It has to not include what's already in the present. So there's already an amount in year 0 that's in the present. When you highlight that, what it's doing is it's looking at the amount, but it's also looking at the spacing. And so it's seeing that in year 1 of the future there was 0. In year 2 of the future there was 12,500. And so it's not just the amount, but it's also the position of things that's telling it what needs to go to the present. So when we close that, it automatically solves for the 78,260. So that's the NPV. It basically renders this entire column obsolete. But there are some cases where it's useful to have this data as well. So just again to demonstrate, what we do in the NPV function is equals NPV, have the reference to the interest rate, and then it would be wrong if I included all of the cash flow diagram. The error would be year 0 is already in the present. The only thing you put into this function should be amounts that are in the future. So just to show you the error, if I incorrectly include what's already in the present, the amount is wrong. We know it should be 78,260. But if I remember, only include things that are already in the future and need to be converted to the present, that's what it does. So the mistake that sometimes people make when applying the NPV function is including what's in the present when they shouldn't. Okay, now for the future value, a lot of the same rules here. Interest rate is a decimal, N is the number of periods or years, but N means something slightly different. It doesn't mean how many years from the present, it means how many years until the future date that we're interested in. Same double comma and the same minus sign that you have to manually key into the function. All right, so what I mean by this new N value, N means something different in the function. All right, I'm pointing to an amount in year 5. Okay, so when you put together your table, you're going to have year as the first column. And so this 11,500 outflow in year 5, okay, it's in year 5, but how many years is it to get it to the future? Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the N you put into your function for this amount in year 5, if you're moving the amount to the future, N should be 11, not 5, because it's in the 5th year, but how many years does it need to travel is what you should be thinking of for what you put into the function. And that's why the column titles are a little different. I've suggested that you have year as one of the columns, and then another column that tells you how many years until year 16, since it's year 16 that we're taking these amounts to. In the third column, you put in the amount that's actually from the cash flow diagram, and then the fourth column is the future value of the amount. So that's where you actually do the FV function. All right, so give it a try, and then after a few minutes, I'll show the solution on the screen. So you'll notice that we have the year column that we had before, and then years until year 16. And so any amount that's in year 0 has to travel 16 years to get over here to the future. And so the way that I did it is I did 16 minus whatever year we're on. And you could have just typed it in manually, 16, 15, and then Excel will recognize the pattern and continue it. So that also works. But I did it initially as a function. 16 minus n gives us how many years it has to travel until it's in the future. All right, and then I've typed in all of the amounts, positive for inflows, negative for outflows, a 0 whenever there's no amount. All right, so now I'm going to use the FE function. I'll increase just a little bit. Hopefully it'll be easier to see if I zoom in. All right, equals FV, parentheses. Now the rate, we need the reference to this interest rate. And it's important to anchor the reference by typing in the $sign before the letter and number, or just pressing the F4 button. Okay, now comma. NPER, the number of periods we're compounding the amount into the future. So $10,000 isn't compounding 0 periods into the future, it's compounding 16 years into the future. And that's why we created this secondary time column. We didn't have to. We could have typed an equation in the function itself, but I think it's more obvious if we have this secondary time column. So I'm going to click there because that's the number of periods it's compounding into the future. Skip over the payment field for the same reasons that I've already explained today, and then the minus of the amount. The minus because it'll automatically change the sign otherwise. All right, $36,887.21. So the amounts are bigger, which makes sense because this $10,000 is going to be gaining 8.5% interest every year. So 1 year after year 0, that amount is going to be worth 8.5% more, and then it just keeps compounding and snowballing into the future. So in the future, the size of this line, see that dashed line, it's going to be really big. 36,000 of this future amount is from the single amount that was previously in year 0. That's the individual contribution in the future for that amount. So now I can continue the function just by double-clicking on that green arrow or dragging it down. But if you just double-click, it'll continue. Of course, it does this by default, the currency style that I don't like. So I'm going to do currency to get rid of the red and the parentheses. And by the way, when it was showing those, let's see, it was looking like this, that just means the column's not wide enough to display the numbers. So those pound signs, all you have to do is make the column a little bit wider. All right, so these are the individual future amounts and we want to find a total. So total equals the sum of this range. And the value of that cash flow in the future is $3,820.67. And so what that means is, if you were given the choice, if someone said, I'll either give you these amounts and charge you these amounts over time, or you can have a single amount in the single payment in the amount of $3,820.67 in year 16, and the interest rate is 8.5%, then it doesn't matter because they're equivalent. So all of these can be moved to a single amount in the future, and this is the equivalent value. Okay, the one last thing we need to take a look at is on the back side of the paper, the unknown rate. I demonstrated that in class on Monday, but I'd like you to have a copy on your spreadsheet. So save your file, the one that you're working on right now. It'll be an important resource when you're working on the homework assignment. Now, although you can't use your homework or your in-class exercise Excel files on a quiz or an exam, anytime you're working on a quiz or an exam, you have to start with the blank worksheet. They're still, these files that you save here in class, I think, will be useful for the homework. So be sure to save your work in a place that you're going to be able to find it again. So let me browse to a location that I know how to find. I'll call this in-class exercise 10. All right, so let's create another worksheet down here at the bottom. And the final question in your in-class exercise today is using the rate function. So remember, the rate function, you're going to put in the number of years, the payment, and the present value. All right, so in this question, a contractor purchased equipment for $60,000, which provided an income of $16,000 per year for 10 years. What rate of return did the contractor realize on the investment? So just to help us visualize what's going on, let's translate that statement into a table. Okay, we'll have year and amount. So this was someone starting at 0, and this cash flow goes through year 5. Oh, 10 years. Does that say 10 years? Okay, 10 years. Let's do 10 years. I think in class previously I said 5, but that's fine. We'll go with 10. Okay, so in year 0, the purchase was $60,000. And then in each subsequent year, it generated $16,000 worth of revenue. So now we've translated the cash flow statement into a cash flow table. And we want to find what rate of return did the contractor realize. Since we're running low on time, we won't go through the sum of the PV of amount technique again. That is in the video, but there's this function that's the rate function. I wanted to show you how to use that. So equals rate, and now NPER, the number of periods that we have these payments. So it's 10 periods. Now the payment amount, I'm just going to click on 16,000. This is 10 recurring payments of 16,000. So this is an instance where we don't want to skip over the payment field, because this is actually an application where it is the same amount n times. So we have 10 payments of 16,000, and then the present value, I'll click on the 60,000, and the note that I gave you in the PowerPoint is that the amounts in each function have to have an opposite sign. So this was an inflow, that was an outflow, a payment. The rest of these are inflows, and so the negative sign there is necessary, otherwise the rate function won't work. Okay, so we're saying what interest rate brings into equilibrium? You know, the balance, the picture of the rocks balancing, or the picture of the elephant balancing. What we're doing is we're finding what interest rate brings the inflow and the outflows into balance. And so in this case, if we have 10 payments of 16,000, the rate of return on this original investment of $60,000 is 23.4%. So here, I'm going to tell us what that is, just so that it's a little bit less abstract. This is the rate of return for an investment of $60,000 when there are 10 annual payments inflow of $16,000. So it's a business opportunity, and if we were thinking of it in terms of the rate of profit or the rate of return, we'd say that this business opportunity returns 23.4%. So that's the rate function. It's pretty handy. All right, 12:49, we're out of time for today. If there was anything that you stumbled on today, My suggestion is go through it again tonight or tomorrow and get practice doing it the right way and solidify in your mind what's the process. Because you can't use these spreadsheet files on the exam. You have to know the process and be able to do it independently. All right, so that's all for today. Remember that your next homework assignment is due on Monday. Please bring your computer again on Friday. And you can get an early start on that homework assignment. There's no reason to wait. You've already seen enough to begin on homework number 5.